Hello, good afternoon, everybody. Welcome. My name is Susan Schmidt, and I'm one of the co-directors of the Region 4 Science and Engineering Fair. Thanks for joining us today. I'm a chemistry teacher at Somerville High School, and right now I'm teaching chemistry completely remotely. I've been teaching chemistry for 14 years, and this year has been really challenging navigating the online classroom. I feel like a first-year teacher learning all sorts of new tricks, which has been both exciting but challenging. So fellow teachers, you may be thinking science fair projects, just another thorn in my side. But instead of thinking of it as a thorn, visualize it as a bud. We are in the midst of a pandemic, but remember that Sir Isaac Newton came up with calculus during the Great Plague in the late 1600s. Doing research, coming up with scientific questions, creating new inventions to help society, these are integral skills in science, what we want to teach our students to do. So I encourage you, fellow teachers, during this unusual time to think of your teaching goals, to step back and reflect on the importance of scientific research and exploration, how you can encourage your students to think scientifically. And you students, I encourage you to tackle questions that you have always wondered about and problems that you see in society and in your community. You can do this at home. You're able to do this. What you learn during this time matters and could bloom into something really fantastic. So now I'm going to turn it over to Brian.
Cool. Hi, everyone. My name is Brian Murnoff. I'm also a co-director of the Region 4 Science Fair, and I'm also the education coordinator at the MIT Museum. And so with this being a very different school year, the science fair has also needed to shift to meet current needs. So this year, we're not going to be having an in-person fair, but we'd still like to encourage students to do really unique, novel science experiments, answer some really good questions. So we've decided to hold our fair virtually this year. It's going to be through a platform called Z Fairs. Not only will this platform allow us to host the fair, but it allows all of the steps beforehand to take place. So registration, paperwork, SRC committee approval will all go through this system to streamline that and hopefully make this as easy as possible. So that registration, and we have a link shown on the screen right now for SRC and registration, that's going to go live on December 1st. Along with that, we also have two opportunities to help your students along in creating their science fair projects this year. So one of these is our community grant opportunity. So we have some grants set aside for students who would like to do science that would benefit their community. So if students design a project that has the potential to benefit their local community, as well as this is for first-time science fair participants, we'd love to help support that. So information and links to that can be found on the Region 4 website. We also have an opportunity out of the MIT Museum to use a scanning electron microscope for projects. So if any students would be interested in using an electron microscope for part of their projects, we have some spots open for that, and there's a proposal also that's available on our website for students to apply to use the microscope remotely with us. With that said, a couple of things as we go through today. So we have several different speakers from different perspectives on the science fair. So we have student who's participated, outside supporters of the fair, judges, teachers who are going to speak about how to best support students during this virtual science fair. During these talks, feel free to share any questions or comments that you may have for the speakers using either the Q&A or chat feature on Zoom. And either after, we'll have time to answer a couple of questions after each speak, and then after everyone speaks at the end, we'll pull everyone together to answer some of the other questions that have come up. So with that, I'm going to turn it over to our first speaker, Albert Farah, who participated in the science fair, Region 4 Science Fair for 4 years in high school. And he's going to talk a little bit about the students' perspective. So here you go, Albert.
Awesome. Thank you, Mr. Murnoff. Hi, everyone. Like Mr. Murnoff said, I'm Albert. I attended Medford High School for 4 years, where I actually participated in not just the school science fair, but also the Region 4 Science Fair and the State Fair. So I'm someone who has really benefited from a lot of the different resources that MSEF has had to offer. So I can actually share my screen right now. All right. And if everyone can see this, I'd like to offer just a couple tips that I've gained, throughout my science fair experience. I think a lot of things that either I wish I knew, going into it, or just things that I learned in general. And yeah, so let's get started. And fun fact, this works for a virtual year too. So a lot of the things that I learned here really just work with the science fair process and can also be applied to a virtual year. So like I said, right now I'm a freshman at UMass Lowell studying mechanical engineering. And all 4 years of high school, I did science fair projects, and I received a lot of help, a lot of mentoring from a lot of different people at a lot of different levels. So throughout all the different science fairs that I attended, I received really helpful criticism from all my different judges, and my teachers really helped me refine my ability to present research. And and before I even start, I'd really like to just thank MSEF for hosting this webinar, actually making it possible for students to get this kind of help, especially during this pandemic. And I also like to thank teachers who are still willing to offer these services to their students and make it possible for them to pursue a science fair project. And finally, I'd like to just thank students for continuing to be interested in science fair. And it's really built on you guys, like, and it's just so much. There's so much that can be offered to you, and there's so much that you can give back to. So in my presentation, I'd really just like to talk about a few general tips, primarily focusing on things that I wish I'd known before I started my first few science fair projects, and specifically data analysis, which I know can be a little difficult when we're in a time when we're like kind of restricted in terms of the things that we can access. So the first thing in any kind of science fair project is really to find inspiration, and what do you want to look into? So as a question to students, I really just like to ask, what do you love to do or think about? And because that's really going to be the basis of your project. And if you can really find something that you're really passionate about, and that you actually just love to constantly think about, and you can really never stop thinking about, that's going to really develop into an awesome science fair project. And if you're kind of on fence with certain things, and you're like trying to look around and see, and just if you're still looking, like, see what might interest you, just try to observe and like question everything around you, and just try to like think, oh, how could maybe this be better, or what are the actual workings of this? And it was like, if there's any kind of question that you don't immediately have an answer to, it kind of just all sometimes starts with a Google, and it's like that can lead to pursuing different questions that really start to interest you. And as you kind of go along the way, it really helps to write down any random thoughts that you might have. So the accumulation of those thoughts will grow into a science fair project, and you'll start to have something that really composes everything that you've been thinking about over, say, like a long period of time. And throughout this entire process, it's not going to be necessarily straightforward, but that's not necessarily a bad thing. So twists and turns really make it interesting. And often when you're doing a science fair project, you kind of start with this big over-the-top idea, like, this is kind of what I want to do. But after you start doing more background research, your vision of the project kind of starts to transform. And it might seem bad at first, but it really just means that your project is becoming more realistic, which is actually good. So it really starts with that, high-level inspiration, that the high-level thing that actually interests you. But as you start to do more research, it becomes more as like, what can you actually do with this idea? And it becomes actually more feasible, which is really awesome. And in my case, specifically with last year's science fair project, I started a little early, so I had a lot of brainstorming time, and I developed my project for around 2 months before actually starting to turn around completely my approach to the problem that I was trying to solve. So the summer before my senior year, I spent basically 2 months developing my idea and, actually reaching out to a few experts in the field. And then by August, I completely transformed my approach to that problem, which actually which was a major step in actually refining my process for my project. Now, I kind of touched on it briefly, but reaching out is actually really important. And it might seem a little harder, especially during a virtual year, but there are actually a few opportunities that open up by being virtual, and I can talk about this. So just overview, anyone you contact will be helpful in some way. So if they can't personally help you, then they'll almost certainly point you to someone who can. And in a lot of cases, they'll remember that they were students too, and that they were asking around for help, with help either on their science fair projects or their research. And they'll remember that it can be really powerful to actually help the student who's coming to them for help. So there will almost always be someone who can help. And it really you just gotta reach out, and they're almost always there. And one of the hard parts actually about reaching out is kind of getting over that initial fear. And because you might kind of see them as, whoa, they're these awesome scientists and engineers at these universities. It's like, how could I ever reach out to them? But it kind of just starts with an email, just starting to, introduce yourself and say, this is what I want to do for a science fair project. Do you have any time either to meet, or could you give me some helpful tips, or do you know anyone who might be able to help me? And I can almost guarantee that they will respond with something helpful. They'll either help you themselves or they'll point you in the right direction, which is really powerful. Now, going into a science fair project, where it's good to have some certain things in mind, and there are some good habits that you really want to develop as you go through your science fair project. Regarding one of the most important things, which is background research, you shouldn't be afraid of academic papers. So Google is a huge, it's a fountain of knowledge basically, but it really requires, just a little technique to actually start sorting through all that knowledge that's available to you. And a great place to start with that is academic papers, and they really might look intimidating at first, but it's kind of just those lab reports that you've been writing for a while now in school. And if you start treating it like breaking it down into those sections and start like reading papers like, as certain sections that you actually want to gain information from, it becomes a lot easier. So starting off, it really helps to look for journals that are related to your project, because those can really point you in the right direction. Wikipedia isn't a bad idea, and in particular, it's a pretty good overview. And as I'm sure you know, there are a lot of resources at the bottom where they actually link things. And Wikipedia is really good for that general overview. But if you really want to go in depth into something, and you really want to get to the meat of whatever Wikipedia is talking about, it really helps to look at those sources at the bottom. And additionally, just some good habits when doing general background research is to kind of keep a list of the links and citations that you find, so that you can quickly access them later. And I can personally testify this, you will need them later and you will forget where they were. So sometimes it really helps to just keep a long list of links and citations and sources that you've been using throughout your project. So a couple tips on reading academic papers. Like I said, it really is just like reading a lab report. So some helpful tips from scientists that in general, there's a really cool article that was published by Science, which is the AAAS. And they kind of asked, how do scientists read academic papers? Because sometimes it's really inefficient just to, go read through it line by line. You have to break it up into small pieces. So what a lot of scientists do is they break it down into the abstract and the introduction, and then they go look through the major figures, so either plots or images, and then they read the conclusion thoroughly, and to get a really good idea of what the paper is actually offering, and to see how much that can actually assist them on their project or their research. And then obviously, as you go through any kind of paper, there's going to be some jargon, there's going to be some terms that are pretty confusing, and it really helps to just dedicate some time either throughout or afterward just to Google all of those terms, because that can really enhance your understanding of the paper. And if you think a paper will be helpful, then you can like go and read into the methodology and the discussions for further clarification. But after reading the abstract and the major figures and the conclusion, you should have a pretty good idea of if this paper can help you or not. And then that'll save you some time to look for other papers that can actually help you really well. Now, this is one of the biggest things of any kind of science fair project, and that is the logbook. And I cannot stress how important creating and maintaining a good logbook is throughout your project. And at the beginning, when you start your logbook and you put those first few lines and it's just one line and you're nowhere near in terms of your thought process on your project, and you're nowhere near anywhere, and you kind of just have this big blank page, you might think that you're wasting space. And I really can't emphasize enough that you're not wasting space. Every little detail that you write down is important in some way. And even though it might not seem like it at first, all those little details will eventually inform what your project becomes. And so all those ideas that you wrote a month ago, they might seem crazy now, you know, all those little things that you jotted down in a notebook, but they will suddenly become very helpful a month from wherever you are. So you'll start to find that you're really dependent on, you know, the initial thought process that you had and how that will inform your project later on. Now, I included a couple of pictures of my logbook from this year, which was, so after my junior year, I decided that I really wanted to maintain a really carefully structured logbook. So I just have a couple pictures of mine that I wanted to share. So I can point out a couple of features. So as you go through, one of the most important things is actually like date every page, you know, so that you can actually reference when you wrote something, so you can understand, because that's basically what you use to contextualize anything you write in your logbook, which is the date. Also, something that really helps in terms of cataloging things is put page numbers. It really helps just to go through and have a good reference of where things are. Note that every page, every entry that you have in your logbook should have at least a title or some general overview of what you're actually writing about. It makes it a lot easier to go through when you're going through previous parts of your notebook than actually having to, you know, peel through different parts of your page and figure out what the heck you were talking about. And also, sometimes it's helpful to actually just write a little blurb about the sources that you use. So in this case, I actually started a little bit on the Wikipedia side, and I just wanted to learn, what was antimatter annihilation, and like what happens with electrons and positrons when they annihilate. So I started with Wikipedia, and that really kind of pointed me to those academic papers I was talking about earlier. And sometimes this is really all you'll write in one day. So as you can see, this was between June 7th and June 8th. And that was really all I wrote on June 7th. And sometimes it's just that much. I will note that this logbook eventually grew to fill the entire logbook, but this is really where it started, you know, just doing that, like those 10 or so lines every day at the beginning. It really helps. And something that's also very helpful is keeping a solid table of contents. So this is basically where you'll organize everything. And the basic things that you want to have in your table of contents is, you know, the page number, as I mentioned earlier, the item, which you know, actually what you're talking about, the title of the page that page number is referring to, and actually just the date, so you can get an idea of how your idea progressed. And you can see that throughout you have a limited space, and this really reflects how organized you should be with your data log, or with your logbook. And basically, you should try and keep your page titles concise, because you're not going to have time to go through your entire logbook again, but it really helps to have those main ideas just presented in the table of contents. And, you know, write some personal stuff. So throughout my project, I did about 7 personal journal entries where I just noted, you know, what I accomplished, you know, what I wanted to do next, and how things were going, and just all things that were going wrong, and just things that I would have to know in the future. And sometimes I just wanted to rant about something that was going wrong or something that had gone well. So it really helps to keep that logbook as like a living, breathing thing. You know, it's really tied to your project and it's tied to you. And yes, occasionally mistakes happen. I did skip around a lot, but it's fine. But that's part of like the living, breathing thing. Sometimes you screw up. And finally, this is your work. Own it. So sign your work regularly. And that's more of just a general, you know, like a management kind of thing, but it really does help to show that like this is the work that you presented. And now some tips that could be helpful, specifically the data analysis, and especially since everything's virtual now. And these are things that I really found helpful with my project last year. And I will note that my project last year, I did 100% from home, actually. So I was basically able to do everything from home. I didn't rely too heavily on resources outside, so I can testify that the tips that I present now will work really well for any science fair project, but even more so during a virtual year. So general data analysis tips. Please note that data from published papers can really inform your data. So if you find yourself looking through academic papers and that were published in different journals, and you find that, wow, this data really reflects a key aspect of my project, I wonder how well I can actually build on this data. And that is a technique, and you can actually use that as a really good way to start informing how you're going to collect your data. And I will note that simulations are a really good path, specifically with this virtual year. I found simulations really helpful with my last science fair project. They were a large part of the core of my project. So specifically during a virtual year, I can say that simulations are a good way to go. And in general, you kind of want to avoid black boxes with your simulation. You don't want to be completely unaware of exactly what's happening with your simulation. And you want to be open to trying different pieces of software. And note that saving your data and how it's generated will actually be really helpful too, because you will forget. And constantly double check, and triple check your data, as units will haunt you at some point, and there will be some kind of error in your data that will mess you up. Additionally, test early and test often, and you should really memorize this mantra, because it will constantly appear as you need to be aware of what you're actually collecting, and gather a lot of data, a lot, and set aside at least twice the time you expect to actually collect data, as it will take longer than you expect, and this will apply to any kind of science fair project that you do. And yes, I mean twice, at least. And really try to set aside some time to mess around with your data and take different approaches to analyzing your data. And keep your conclusions and any generalizations that you make really closely tied to your data. And finally, some helpful resources that could, specifically during this virtual year, that I found really helpful last year. All these different links are for either academic papers or different software packages, and sometimes just how to read a scientific paper. And finally, thank you for your time, and I'd love to take any questions.
Well, thank you, Albert. I think we're gonna, at this point, for questions, we're gonna save them to the end. I think we're gonna move to Megan. So Megan, if you want to share your presentation and introduce yourself, and we'll get started. Okay, Megan, your audio is not coming through.
Oh, sorry. Are you seeing me as well?
Yep, now it's going.
Okay, great. Thank you, everyone. Albert, I really appreciated the fact that you emphasized the importance of a log book or a lab notebook. That's something I really emphasize with my students that I work with as well. So my name is Megan Spencer, and I am an educator, but I work at a pharmaceutical company. So I work at Novartis Institutes for Biomedical Research in Cambridge. And I have the opportunity to work in a community lab space. So I quickly wanted to introduce this community lab space and share information about it, and then talk about how I support the Region 4 Science and Engineering Fair. I'm also a member of the Region 4 Science and Engineering Fair Committee. So the Cell Novartis, that's our acronym. Our purpose is to excite youth about biomedical science. When we are able to interact in person, students perform hands-on activities within the lab space, and it's an authentic biomedical laboratory setting where students are actually able to interact and work.
Megan, your audio is not coming through clearly for me, at least.
Is it not? Is it the same with everyone else?
Yeah.
Okay, let me just. Is it better without the headphones?
No, not better yet.
Okay. right. Is this better if I just hold up my microphone here? Can you hear me better?
No, it's still very low level. Pick up there.
Any better? Let me just see. Can I? All right. Does there sound any better here? I changed the microphone and the speaker setting.
Yeah, now it's great. Thank you.
Okay, great. Thanks for letting me know. Okay, so let me go back. Can you still see my slides?
Yep, slides look good.
Okay, great. Thank you. So we work with secondary students and adult learners. So we often work with programs for adult learners that are people that are interested in a career change. And we try to work with the local Cambridge community as well as students that are part of the greater Metro North area, Boston and beyond. We've had students even come from Portland, Maine to come down to our lab if they were visiting Harvard University and do an experience. But of course, this year, everything is a bit different and we are transitioning to virtual content. So our mission is to engage our community about biomedical science and inspire local youth about careers in science. And we do this by really connecting students with Novartis professionals by either working alongside the students in the laboratory experiences or just having conversations with them. And that's what we're really highlighting right now in this new virtual world. And we hope that these experiences will expand scientific literacy and also inspire the next generation of future scientists and STEM professionals. So, as I mentioned, the cell goes virtual in 2020, and this is how all or most educational programs are going. But so we are creating one-on-one virtual mentor relationships with Novartis scientists and local students, and we're doing that through our STEM Club at Novartis. And this is a program that encourages students from the Cambridge public and charter schools to apply and to be paired with a Novartis scientist or STEM professional mentor. And I'll talk a little bit more about that. Other things that we're engaging with, and this is something that if there's any schools that would like to reach out to me, are virtual career panels for students to have candid conversations with Novartis professionals. I'm actually hosting the next session will be a panelist with Novartis professionals after this. And then we're also adapting some of our existing expeditionary learning content into virtual content that we hope to make available soon for open resource learning for both synchronous and asynchronous. So the virtual STEM Club at Novartis, this is an opportunity for students from Cambridge public and charter schools to apply. And each participating student is paired with a mentor that is a Novartis STEM professional. So both the students and the Novartis STEM professionals apply to participate in the program, and then we match the student and the mentor based on the project or the interests of the students and the expertise of the person, of the Novartis professional. So it's really a student-driven program. And I think anyone that's participating in the science fair or completing a science fair project needs to be driven and self-motivated. It really does require accountability to make sure that there's effective communication between the student and the mentor, and that the student is doing independent research on their own as well. The student and the mentor meet weekly, so what we hope is that between those meetings, the students will be working on their project outside of the STEM Club designated time. They do communicate, the students and mentors communicate over email throughout the week, and we often host general information sessions sort of about deadlines, other professional learning, or science fair project related topics. So the students develop their own question, they perform their experimentation, and then of course they'll complete a virtual science fair project this year with the hopes of participating in the state science fair. So these are a few stories from our students, past students. So there are now current undergrads who are alumni of Cambridge public and charter schools and participate in the STEM Club either once or twice. So the student from MIT said, the experience I had in Cell influenced my decision to study STEM. This person is actually going into computer science, but he felt like he really developed some problem solving skills from his experience in Cell. The student from UMass Amherst enjoyed learning from professional scientists and performing experiments, and again, developing those problem solving skills. And is going on to pursue further science education. So you can read the rest on your own, and I'll give you a few seconds to do so. And I think it was really exciting to receive this feedback from students about their experience in the STEM club. And I continue to look for feedback from past participants to see how we can improve the program and help students as they pursue further education down the road. So the virtual STEM club at Novartis is unique to Cambridge students that are attending either Cambridge Rindge and Latin Community Charter School of Cambridge or Prospect Hill Academy. But this doesn't limit the fact that students outside of those schools can try to find a STEM mentor. I've provided some suggestions on how to do so. So asking a science teacher if they have any connections in industry or academia. Maybe they were in industry or academia at one point and still have connections. Reaching out to local STEM companies or universities. I find that within my organization, there are so many people that are interested in working with youth. And I know that this is similar for other local companies as well. And then connecting with STEM community programs. Cambridge has a plethora of community programs, and I believe that they're most likely able to provide different suggestions for mentorship support or have connections to local institutions. And I also think that the Region 4 Science and Engineering Fair is a resource for students. So we had over 60 volunteers that judged the 2020 Region 4 Science and Engineering Fair this year. And these are some of the institutions that they represented. So just knowing the fact that there was maybe one or two or maybe more associates from these different companies that and institutions that participate in the fair, that there's definitely interest in helping students pursue and complete a science fair project. All right, that is the end of my presentation. Looking forward to receiving questions at the end.
Hello, everyone. My name is Karen O'Hagan, and I am a Program and Outreach Specialist in the Department of Chemistry at Tufts University. I have served as a judge for 4 years at the Massachusetts Region 4 High School Science and Engineering Fair. Joining me today is my colleague, Sergei Kryatov.
Hello, my name is Sergei Kryatov. I'm a lecturer of chemistry at Tufts University. I have been a judge for local science fairs for about 10 years. And this year, of course, is very different because it's difficult to gather in groups for safety reasons. However, even at your home and around your home, you can find enough living and chemical and physical objects to maybe design some interesting experiments. And then, if you really think well about those experiments, plan them well, execute them well, maybe repeat as many times as you need to kind of make sure that you get what you want from them. So those experiments, if presented well, will impress the judges. And also very importantly, from the start, think about safety. So there are enough, dangerous objects inside of your house, electricity, natural gas, different chemicals. So work carefully with them, wear protective goggles, gloves at the least, and, think what can happen and have a plan. So that's just kind of very basic suggestions to start.
And I wanted to echo that learning that you are prepared before you start your project this year is really important to us, as we all recognize that you are taking this on or self-guiding yourself through many of these steps. Today, my colleague and I are going to share some other, our different judging perspectives on some additional information that you can prepare to present during the competition, which we think will improve a judge's reflection or review of your project. To begin, I wanted to share with you what my favorite question is to lead with, which is to ask students, what got you interested in this topic? This is an opportunity to share with a judge your personal connection or passion for a research topic, as well as its significance.
So again, I want to review briefly what was presented before. So types of projects you can carry out probably very different. What Albert talked about was a more theoretical project. It was on the intersection of physics and computer science. And he did all of it on his computer. But other types of projects that involve biology, chemistry, and physics can be experimental, where you plan some experiment, carry it out, see what happens, analyze the data, and check whether your experiment proved your hypothesis or disproved it. So it can happen both ways. And again, all this planning, if done carefully, will let you enjoy the science and impress the judges in the end.
But something else to consider, you might want to provide not only a clear account of what you actually did, but also your understanding of why you did it. It's important to us to hear both any hurdles or troubleshooting you did to iron out your procedure, because from a judge's perspective, this gives us a view into your entire research plan and the methods that you're using in your experiment, which we value.
Yeah, so again, repeating many times may at the start appear boring, but that's how science works. So analysis of the data sometimes will lead you to the need to maybe repeat an experiment or investigate additional resources on the internet. Research and science are, very time consuming. So, well, maybe you will not be even able to achieve everything you planned for, but, starting somewhere is a good idea.
And one other thing to consider within your concluding remarks is to be sure to mention the impact your project may have or what possible future directions you might pursue.
Yeah, so from my own experience, I can tell that pretty much no research project can be completely ended. There's always next step. And so plan for that. And your project does not have to be complete before presenting it at the science fair. There are some time constraints. Keep that in mind. And also even presenting at the science fair can be a learning experience. When talking to the judges, you can, get some ideas from, their questions and maybe some suggestions. You will, on a science fair, you will typically get 3 judges. And just a tip from me, when you talk to the first judge, pay attention, make some mental notes. And then before you get your second judge, maybe you can even get, some ideas suggested by the first judge to answer your second round of questions better.
And it's good to consider these remarks too to shape your next step or your project in a future fair. We've seen projects evolve from judges' comments from year to year.
Yeah, and it's probably time for us to conclude. So again, finally, please, safety, that's very important. If you take an experimental project and work with, chemicals, biological agents, or, physical forces, be careful with them. So please be safe.
Cool. So we have a few minutes left in this webinar, so I'd like to welcome all of the panelists back on. And if you have any questions, feel free to throw them in the chat or question and answer, and we can answer them.
I'll throw the Region 4 slide back up. Oh, we have a question here. What is the structure of the science fair program in a school? So I think that this varies from school to school. Some schools, have a very dedicated science fair program where all classes of a certain grade participate, or all students in a certain subject participate. Other schools limit it to students who are just interested. Some schools may have a science fair club after school where students who are interested get together each week and do projects together. So it varies from school to school, and the thing to know is that it's flexible. It doesn't have to be something that you do in one way. That being said, probably the most participation comes from schools that have dedicated a grade or a certain class to science fair projects and make it an integral part of their science curriculum. So many students look forward to it. Some students dread it, but either way, the projects that come out of it are very interesting, and students get to learn about how to do research this way. I don't know, Brian, if you want to add anything to that.
I think that sums it up pretty well. Yeah, it's really varied. But the big part I would say is having someone in the school that can act, or in the school or out of the school, that can act as a mentor to help students in the process, whether that's as a class or off to the side, someone who can help guide and help students develop those really interesting questions that they really want to answer for part of the fair.
Okay, so I'll put up our information again, and please do email us if you have any questions, whether you're a student or teacher or a potential judge that might be interested, or you're interested in learning about how to mentor students for science fair. So let me throw that slide up again.
And while that's going up, we did just have another question come in for Albert. Did you have any specific support or mentors during your own research?
This year, or my senior year, my physics teacher, Dr. Wadness, was basically throughout the entire process, I think, the biggest help to me the entire time. Yeah, I think almost every day I would go to him. Basically, it would just be updates, and he was one of the driving forces that really pointed me in each direction. So teachers are really powerful when it comes to helping students, and it doesn't and especially when there's like communication between the teacher and the student, that is incredibly powerful.
So I think with that, we'll probably wrap up, but thank you all for joining us. We're excited to see what science and engineering projects the students can produce this year. So happy sciencing.